We'll come to the another thing, that is the propositional logic. This is actually in the beginning of the chapter only, but after this portion was included in the syllabus, so I teach at the end only. So it is easy. First you see propositional logic. What is the proposition? It is a procedure to provide reasoning through statements. It is not getting not clear. You just come to the what is proposition. A proposition is an elementary atomic sentence that may either be true or false, but not otherwise. See, already we have done truth table, true, false we have seen. So that only before that, this is actually the first idea of the truth table and the Boolean algebra. This is how the Boolean algebra develops, and this is means how it is implemented into the day-to-day life, day-to-day situation. So there means how we are adding it into that concept. That is proposition, that it is coming there. So it is each and every sentence that is either it should be true or false, then you can consider as a proposition. Like grapes are sour, it is a proposition. It can be 0 or it can be 1. It can be sour, or someone say no, it is not sour, so it is not sour. So that is not sweet. So that can be sour or sweet. So there are two possibilities are there. So this type of statement can be a proposition. It can have two, means the yes or no. And here, where do you live is not a proposition. You cannot ask question, or you cannot get any answer of this. Where do you live? 0 and 1. So there are all sentences are not the proposition. There are the sentence if you get true, false, or yes or no, this type of answer, then you get a proposition. This I have given you in the notes. Many examples are there. You can see it from there. Just I am clarifying it so that you have no difficulty to study. Now this proposition, this is all simple proposition, like this one, grapes are sour and all. These are the simple propositions. Now a simple proposition is one that does not contain any other proposition as a part, like a grapes are sour. So these are, you can see these grapes are sour. This is just nothing, but this is a proposition where we can have simple sentence. So this is the proposition. Now mean the simple proposition. Simple proposition can be multiple proposition also, because the two sentence with and or not, we can add it with that. That then will come to the multiple proposition. Multiple proposition. I am coming to the next is a multiple proposition. So this is a simple proposition. So I hope the proposition is a little bit clear. Now we are coming to the multiple proposition. Multiple proposition means the proposition where there is a two sentences. Now see the multiple proposition or compound proposition. It is raining and wind is blowing. So here it is raining, one proposition, wind is blowing is another proposition connected by and. So this is one compound proposition or multiple proposition connected with this and. So this type of, now we are coming little bit closer to the and or and. The words and or can be also used, or not also can be used, are called connectives. These are called, they are connecting to both the sentences. So this is also called the connectives. So these connectives are represented by a symbol. This is the or symbol. This is and. This is if then. If I am coming to this because this is not your thought, little bit are there. I will tell you. This is if then and if and only if. These two I will tell you. And now this is a not. These are the connectives. Already you know about the application of or, application of and, application of not. And these two I am coming, and these are called connectives. So there it is used in case of multiple proposition. Now you see different terms related with the connectives. There are different connectives. I already told you. It connects between two. It present between the two. This one your expression. And now there are different types of connectivity. It can be and. We are already familiar with the and or not. Then if then and if and only if. Now you see the and there are symbol. I use so far. I use only this symbol as a and. Like x dot y means x and y. This can be, instead of this symbol, it can use this also. That is not told. Now I am telling you. So you have to expression instead of this. It may give. This is also and. This is also you can give and. So there are three symbols. Generally this one not much used, but this is used quite often. So that is your and even it can be told as a conjunction. Conjunction means also and. It is saying we may not say and, it will say conjunction. Conjunction means you have to understand this is a and actually. Now or. So or means it is a disjunction. Disjunction, this is a symbol that we are familiar with this symbol, and then this type of symbol are also there. So these two symbols are there representing the or, and this is also called the disjunction. Instead of or can be written disjunction. Not, it is called negation. Negation, this symbol are there. This is there already. I told this is also bar, and this you can write it like this way. This is a bar. Can be like that, it can be like this, or it is a symbol of not. So this is the negation, not. If then, it is called implication. If then, I am coming details little bit about the truth table. If then, this is a implication. This symbol is this. This is just an arrow only. It can be said like that. This type of arrow, this type of arrow, or it can be like a set symbol. So this is like x, this symbol y, then x if then y. X if then y, x if then y. Now if and only if, that's two are included. If and only if, it is called equivalence. Equivalence already we have learned when we are doing the logic gates, the Boolean algebra logic gates purpose. Then the XOR, XNOR. XNOR is also called equivalence. Remember this XNOR, it is the equivalent. That this one, the symbol is a complement, the expression is a complement, b complement plus a b. If you see the notes, it is there. The equivalent means is the same thing. This is the logic this one expression of the equivalent. This if and only if is also called equivalence because it gives the same truth table. That's why if and only if and equivalence is the same truth table. Each representation is like this. This is the arrow in the both sides. It means this is this type of thing both ways, or it can be written like this way. So this is equivalent y and it is also equivalent y. So these are the all are there. Now I am coming to the if then and if and only if with the simplest way because we don't have to know much. If then and only if then what the truth table and what is the little what is the difference between these two, that you have to know it so that you can apply it. So here the truth table of if then and this is the truth table of if and only. See, if then this is a truth table way we will remember it. I see here there are two variables x and y 0 0 1 1 0 1 0 1 and here x y, that x if then y. So here I have given you when both the it is 0, so then it is 1, 0 1 is 1, 1 0 is 0 and 1 1 is also 1. Now you have to remember this way, when x is 1 and y is 0, then the output only here you see only one case it is a 0 in this case. This case it is a 0, so the rest all are 1. So when x is 1 and y is 0, when x is 1 and y is 0, that time only it is 0, rest all are 1 only. That way you have to remember it. You will not go in details about the why it is coming or not because it requires this much only, and it is you have to remember this, that if then this it is only one case it is 0 when x is 1 and y is 0, then it is 0. And now when it is truth table of if and only if, then you see exactly same thing. When both x and y is either 0 or 1, the output is 1. So here both 0 is also 1, both 1 is also 1. So these two you have to remember so that we can in a truth table we can make use of it. If when you have to draw the truth table of the if and only, you have to remember if the all are 0, both are 0, then only it will be 1. When all are 1, then only it will be 1. And here it is when x is 1 and y is 0, then only it will be. This way you have to remember these two truth tables, and then we will apply it how it is with actual question, what type of question it comes accordingly. Now or next I will show you. So this is one question, board question. You can see, draw the truth table to prove the propositional logic expression A if and only if equal to A if then B and B if then A. So this is you have to prove left hand side and right hand side. See, my left hand side is 1 0 0 1 and right hand side also 1 0 0 1. Here I have taken two input, and now this is if and only if. When both are 0, then it is 1. When both are 1, that time also it is 1. Now if then here it is if then A if then B, A if then B. When this one is A is 1 and B is 0, that time only it will be 0. Rest all are 1. So this is the case, it is 0. It is. Again B if then A, B then when B is 0 and A is 1, that time will be the B is 0 and A is 1, that time it will be. So here this is the case. Here it is B is 1 and A is 0. Just the opposite. Here this one was there 0 when A is 1 and B is 0. That time we are giving this one 0, and when B if then B is 0, B is 1 and A is 0. That way it is coming to this. So this again you have to make a between these two. You have to make a not. Not means it is here. So this is not no and. This is and. So and is this when both are one. It will be and is when both are line current passes, then current will go. Here current will not go. Here current will go. Here also current will go. So here in this case, so this and this is the same. So you have to answer is this only, and you have to check it with the. So this is the question and this is the answer. And this type of question only comes from if then and if and only. I'll give you one more example of this. So this is another question. Determine if following WFF is valid. What is WFF? Note it is there. The welfare formula is valid. Means the proposition is also called WFF. The following WFF is valid, satisfiable, unsatisfiable. Valid, satisfiable and unsatisfiable. What is there also it is note I have given you separately. Now you see here when we say valid, when you say satisfiable, when you say unsatisfiable. That details I will come again next class. Now you see this is the expression P if then Q, then again if then, and then this one not Q if then, and then not P, and then this one not Q. Now so there are two variables P and Q only. So we started with two variables 0 0 1 1 0 1 0 1. Now first we have made a P if then Q, P if then Q, because it is a simple expression. This is not left hand side and right hand side. Simple expression what is ultimately we are getting. So first we made this P if then Q. P if then Q when A is 1 and P this one is 1 and this is 0, then it will be 0. So accordingly we made, and then not Q. Not Q means this is your Q. Not Q. 0 will be 1. 1 is 0. 0 is 1. 1 is 0, like that way. Not P. P is also 0 0 1 1. So 1 1 0 0. This is the opposite. And now again this is the this between these two, and so here it is this one 1 1 it will give you 1, 0 1 is 0, 1 0 is 0, 0 0 is also 0. This is your and now along with this again this another one. So this one we made it, and now this and this you have to make Q not Q. Not Q is here and this one is here. Between these two you have to make a if then, and if you make a if then it is coming 1 1 0 1, and then after that this one whatever you are getting. So along with this one and this one, first one we have to make the again if then. This is the if then again. So first we made the if then we made a note of all this, and then we made this, and then it is the if then, and now this if then we have to, this is one bracket, this is another bracket. So between the last we are doing this operation, the whole operation between this operation will be done at the end. This one we have done, this we have done part by part, and then ultimately between these two we will be doing the operation. And then this one and this one with the again if then, again you have to do the if then. So if you do if then, you will come to the 1 1 1 1. So if all the 1, if the WFF is valid because all are giving 1 here and satisfiable. If there is any 0 are all there, then it is not a satisfiable, not a valid. So that is here it is. So here all the output is 1. So you have to write WFF is valid and satisfiable.